Making Stuff by Rob Miles. This is the second part of some videos I've made on the back of a rather useful seminar I gave at the University of Hull, all about self-promotion and making stuff. The first one, the self-promotion one, that was part one. This is part two, making stuff. We're going to look at how we make stuff, what stuff we can make, and marvel at the fact the word stuff covers lots of things. Wonderful. Moving on then. Okie dokie. Stuff you can make. Yeah. Basically, everyone should be making stuff. In the first video, I say things like you should promote yourself and tell folk what you've been doing. And if you've got the question, what is it I should be doing? What can I talk about? You know, made the tea this morning. Big whoop. Yes. Let's have a look at things you can make. I'm going to look at some things that I've made because what the heck, I like showing off. And I like taking an idea and seeing how far you can go with it. With a bit of luck, you might have some ideas of doing things that are better than mine. And if you do, then that's absolutely wonderful and fantastic luck to you and all that as well. So let's go through a few things and we'll spin off and then we'll try and find a way forward in terms of how you can take some of these ideas and do stuff with them. And so let's go and take a look at my Pomodoro timer. Yes. Now, the Pomodoro technique was invented by an Italian, I think was a name like Francesco Cirillo. He probably is Italian, I think he is. He's had a kitchen timer like a tomato, a Pomodoro tomato apparently, and he found that he could get things done if he set this for 20 minutes, worked for a while, stopped for a while, and then repeated that process again. And so I thought this was kind of useful. He managed to, there's a book called The Pomodoro Technique. I'm sure there's more to it than that because he had to fill a book somehow, but it's out there. You can read it. And the basis of it, though, is this timer. And I thought, I'd like a digital one, please, because I'm a computer person. And what's more, having watched all these reality shows where they have someone going, you have 10 minutes remaining, and all that kind of stuff, I thought, wouldn't it be great if it spoke to me in my own voice? So, well, I made one. And if you want to see it, then I've got a carefully contrived and constructed camera which shows you the thing sitting on my desk over here. So if I just slide over, what I have here is a little box and I can turn the knob and I can tell it how many minutes I want it to run for. Let's go for 10 minutes. I can hit the button to start it. I want to count down, please. That's fine. I can then say I'd like a display. It can announce 5 minutes left every 5 minutes or whatever, which is kind of okay, but I'd be a bit boring during this talk. So I'll just say I want the display and nothing else. So I'll go boom. And when I press go, the timer starts. And it's counting down now in minutes from 10 minutes. And if I want to find out how much I've got left, I press the button and it goes. You might not hear that. I'll try it again a bit close to the microphone. 10 minutes remaining. And you'll be wondering how I got all those voices into the box. It's amazing, isn't it? How on earth did he do that? Well, if you open the box up, inside we've got an MP3 player with an SD card in it, which has got about 120 recordings of me going, 11 minutes remaining. I could have just done the 11, but whenever I tried that, it sounded like a really dodgy answer phone thing. So I thought, since I've got enough memory, I might as well do every single minute as its own freestanding thing. And it sounds a lot better for that. And so I was sitting down here with a copy of Audacity going 10 minutes. My wife thought I had gone insane. Well, she might not be totally wrong about that, but let's move forward. I then put those into an SD card, plugged it into the MP3 player, wired that to the speaker, had a Raspberry Pi Pico, which is this guy here, running a program in Python, which then reads the rotary encoder and the switch buttons and displays all the display stuff and pulls the time out. And that's my Pomodoro timer. And you've seen it work. And work it does. Interesting facts, the bits and pieces in, that's probably cost about £2, plus a couple of quid for the SD card. This one costs a £5. This thing here is about £6. This thing here is about £4. This thing here is about £1, maybe less. This thing here is about £2. So won't cost much to make. And of course, it's in the Raspberry Pi magazine as a project too. And you can find it on GitHub. And you can also do all kinds of good stuff with it. It's got a rather nice 3D printable plastic case. This is the design for it. This was done with a tool called FreeCAD, which is a free 3D drawing tool, a design tool. It's brilliant, it's free, and it's awesome, and it does all kinds of stuff. If I'm giving you top tips for life from Rob, one of the things I would say is learn how to use 3D design tools. Learn about the magical property of Z and how sometimes it comes up through the floor and sometimes it comes towards you horizontally, and learn how to sort of think in 3D a little bit. I don't think you have to be a graphic designer to be able to do that, and it really has big benefits all the way through. Now, because I'm a programmer and a very poor graphic designer, I did all my design for this box in Python. I've got 3,000 lines of technical debt. This is my my box building program. I tell it where I want the pieces to be, and it then builds the box and puts all the pillars in for mounting them on and all that good stuff as well. If you want to see what that looks like, well, here's the program that makes the box that the Talking Pomodoro lives in. And it's basically, I make a Pico object, I make a holder to put that in, I then make a media button and a rotary pot and a small speaker and an alpha seg display, the little display thing, and a speaker holder which takes the speaker and the button, and a button holder that takes the grid, takes the lead, the space and the spacing between the two, and a pot. Then I feed these into my case object, ask it to do the make parts, and boom, it does that, and the case drops out. Now, I haven't released this program to the world because I'm kind of embarrassed by how wobbly it is, but it illustrates that you can take things that aren't really supposed to be programmed, like designing stuff in a 3D CAD package, and you can write code to do that. So if you're thinking in terms of, well, I'd kind of like to have all my team stats as a beer mat, then why not do that? Why not write a Python program which takes in your team's stats for football or cricket or whatever, and then makes a beer mat with the height of the nibbles and bits on it being different scores? It's all possible. It's all doable. It's all code. And so why not just do that? But we're going to keep moving on because I've got more things to show you. So I'll move that out of the way, although you can't see me moving it. And look at my chord keyboard. Now this is harking back to way back in the past when Robert, when I was young and in my prime, I had an agenda, and you're going, what on earth is one of those? And it's one of these. It has pads on it where you can press chords to do typing. And the idea is that you don't use the A, B, C, D keys because they're a pain. You rest your fingers on those buttons and you press them in particular combinations to make letters. And I could sit and type notes in meetings when no one knew what I was doing. It was great. And I used to use it quite a lot. I wrote some code for it. Then the phone went bust. The mobile phone came in and took away all that and sort of market for PDAs and whatnot. And we are where we are. But I fancied I'd bring it back. So I made myself a chord keyboard, and that's a picture of it. And this is the thing itself. And you basically turn it on and plug it in. If you don't turn it, you plug it in and it appears as a keyboard. And because I happen to know the shapes of the keys from muscle memory from way back, I can show you me typing with it. So all I have to do is go fetch my editor. Where's my editor? Oh, it's down here, yeah. It's got a weird name because I've been just pressing buttons to see what happens. But if I get this going, I can just move it so I can see it better. So now I can type T is, if I put my hands over here, which you can't see. Yeah, I should think these things through a bit better, shouldn't I? Let's do that and just slide that over there like that, and then make this a bit smaller. This is great, isn't it? I do this in front of an audience usually. I get these things wrong in front of an audience professionally. But now you can see. So if I go, that's T, 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 and then D, Q, U, I, C, K, Brown, W, and Fox, and so it goes on. If you watch me typing, and I would advise you to do this, and then HELLO, world. World, I said. I can go back if I want to. But anyway, it's a chord keyboard, and trust me, it's wonderful. Trust me. And so I built this thing, and I can use it to type things, and it has a training mode. I use keys that light up because I thought that would be kind of funky, so I use this, and I can prepare text with it, and it even prints a help thing out. If you press a certain key combination, the keyboard itself types into whatever you're using at the time. A little map that says help is that one, and start the game is that one, and then it does it for all the tricks. There's a game where it displays text you have to type in, and all kinds of bits and pieces, and lights up with the cues. So it's kind of like a fun thing. It's about 500 lines of Python sitting in there doing all this, which is quite sweet. And then, yes, I thought, I've done that. I'll make some left-handed and right-handed ones as well. Well, why not? And I'll put Bluetooth in them so that we can actually send the keys that we've pressed to other places. How wonderful. So I did all this and got it going. And I found that, yes, I can type with my left hand as like a mirror of my right hand. It makes your brain come out of your ears a bit, but it does work. They're battery powered. They hang off Bluetooth. And they use a printed circuit board. And this is something else. This is another new thing you should try. Printed circuit boards are stupidly cheap to get made, particularly as everybody, all the companies, PCBWay and the other one, I can't remember the name of, they all give you free. The first go you have is usually free. So your first PCBs can be made for nothing, and all you really pay for is the actual postage, which is kind of expensive from China overnight or whatever, but it's still doable, and you can design your PCBs using a free program called KiCad, which again is well worth learning. And so now you can create your circuits and then have them printed. You can also do business cards and anything, because you can print text on these things too, and you can make some really fancy looking stuff at very, very, very low cost. And so, yeah, you should take a look at how custom PCBs work. I made one with only 2 faults. That's what these little black wires are for. They're actually where I had to put my own surface fixing. This guy here is Raspberry Pi Pico. That's a little OLED display. I can move the buttons anywhere I like on these columns, so I can have left-handed or right-handed ones depending on how I feel. And then this thing on the bottom here is a little rechargeable battery controlling circuit to actually keep the device powered up. And so that all kind of works. From a code perspective, because I do likes me programs, why on earth did I do that? Is that a pirate? Or who knows? Anyway, I've got a bunch of code here which is running inside the FreeCAD tool to design the box that goes around my circuit board, because I've got programs running in both the KiCad to put the buttons on the circuit board and also in FreeCAD to cut the holes where the buttons are going to go through. And I'm going to be absolutely sure about the fact the two are going to line up for 2 reasons. One is it's the same code. These number properties here are the same across both platforms, but also because I can import the printed circuit board into the PC, into the actual box design, and then I can lay one on top of the other, and I can actually see for myself it will fit. Now this again is great fun, and you should do this whether you want to actually make your own hardware. This is just a great thing to have fun doing. So that was a thing I made, and yeah, that one went out there, and I moved on to the the wonder of music. And I made a bunch of devices that can play music. Okay, they can play notes. Music's probably pushing it a bit. And there's a chocolate synth box there. There's the... Oh, my Pomodoro timer's just kicked me out, but I'm going to keep going, whatever. That's the synth box. That's the Crackers controller. And this thing here is the cheese box. MIDI cheese box, which has got... I wanted to see how far you can get with 12 buttons and a 12... light LED ring in terms of making music. And so I thought I'd build a sequencer like that, because why would you not? So I did. This is inside the music making part. We'll do that first. And this is basically a Raspberry Pi with a sound card on top, and then it has a Raspberry Pi Pico designing the display, because I wanted coloured flashing lights, because everything, and I mean everything, is improved by coloured flashing lights, including this. So there's 2 speakers, stereo sound, and there's some rotary encoders at the top. All that's handled by this guy, which then sends the movement information down a serial connection to the actual Raspberry Pi via those 2 wires there. And it works, and it's kind of fun, and it's kind of big and kind of hefty to carry around. It uses a thing called Pure Data, which I really like. Again, another thing you can get into, if you're into music and you're into sound and you want to make some sound synthesizers, then why would you not? You don't make music by writing code. In Pure Data, you make music by wiring things together. So this is the signal at the top. That is the trigger to make the sound. It goes into a box that makes a line that starts at 0 and goes up to 1 and takes 200 milliseconds to do that. Then we take the square root of that and we get this, which is kind of like steep at the front and then goes up. Then we take that and we multiply it by 20 to sort of create a waveform rather than just an envelope. And then we take the cosine of that, having first shifted it by a quarter of a wavelength to make sure that it starts going up and not in the middle. And then what we get is this thing here, which is like a sine wave that starts off close together and then gets longer and longer. So it's a high-pitched note that gets deeper really quickly. That, my friends, is a tom-tom drum. If you hit that, it sounds like a tom-tom. And that's how they make them in synthesizers, all as a piece of pure data, which is nothing at all to do with devices you could make. But if you fancy making any kind of sound manipulation stuff and want to use some free code to make some amazing stuff really easily, which runs on a Pi or whatever, take a look at pure data. Interesting digression. I found a box that replaced the Raspberry Pi with a little tiny thing which costs about 10, 12 quid, and it will actually, you give it a MIDI note. MIDI's a musical standard for sending note information around the place, and it plays that in tons of different voices, and it only costs a few quid. And I thought, well, I'll take all my MIDI cheesebox stuff and I'll put it all in one big thing, and that thing, he said, building up to a fever pitch, is coming next. So I'll move that out of the way, and I'll get hold of this chap, and hopefully he'll wake up and do the right thing. He has done. There you go. It has a slight lack of that. You can hear the note that it makes a sort of noise when the notes are when the display is lit up. It'll display text and stuff. The camera's not really doing it justice, I'm afraid, because of the lighting in here. But it's saying hello world, and in a minute or two it'll stop doing that, and I can start pressing notes. I can make it a bit louder so you can hear it better. You should be able to hear that okay. If you can't, then I apologise. If I want to, though, I can start making a sequence. So this is my sequencer, and I can start putting bass drums in. And then I can go on to the next track, and I can put in some cymbals. And I can then sort of go to the next one and put some more in. And the idea is that you can do that and get it going, and then you can play along with it. Now, there's lots of other things you can do too, and there's all kinds of various settings. And you can lengthen the sequence. You can adjust values using these trims, and all kinds of fun. And you can sit there for ages fiddling with it. And I know this because I have done that. It's a Python program running inside a Pico that makes everything work. And it's kind of fun. So if you want to play with coloured lights and moving things and whatnot, and all the code for this is up there somewhere in the cloud on GitHub, because why would it not be? And so that's another thing you could make. And I'm wondering why my mouse isn't working. I'm just pressing the button and nothing's happening. Last time I did this, in fact, this is about the 15th attempt to make this video. Everything crashes around about now, when I think this is going very well, I'll be fine. Then everything falls over, and I think PowerPoint has seen it. Decided to crash on me, so I'm going to go back here and restart it, which is how you fix everything apparently from current slide. That'll do. Let's go back a little bit. Oh, this is right. Okay. So that's my cheese box, and that's fine. It did crash, and it wasn't my fault. Honest. So here we go. Final thing. Well, one of the final things. The final big thing I make, and then we go into other bits and pieces. The red phone. Now, I went to a shop and saw a phone in the window, and it's a red phone. Oh, Batman had one of those. Oh yeah, I want one of those. So I bought it, and it's great, and you can make phone calls with it, but that's boring. I wanted to do a bit more than that, so I thought I'll put some intelligence in it. So I took the bits out and I put a Raspberry Pi inside there, along with some voltage converters. Now, old style phones have mechanical bells that sound awesome, and the newer ones have got digital sort of sound things that sound rubbish, but I wanted to use the original, the proper bells. So I got this thing, and if you look down here, the actual bells underneath this bit, but you can just see the top there of the mechanical. There's two solenoids that pull this thing up and down, and they cause a clapper to actually bash against the bells and make the ringing sound. That is how they work. Now, in a real phone, this is all done by a 70-volt signal that comes down the line back in the day, which is quite toasty. And if you got that up your armpit, you would notice. So I halved that voltage to 35, which is what this thing does, and then I sent the different voltage to each side in turn under the control of these two guys on the top, these driver guys, which flip the voltage backwards and forwards. I'm doing a thing with my hand that will make it much easier. Whatever. And so I can control the bell using the magic of software, okay? And it took me a while to get it to sound like it should. And once I did that, I had Raspberry Pi in there as well, which will do all the audio stuff and also host a web page. So you can go in here and you can type a message, hit send the message, the phone will ring. When a person picks the phone up, it will then read the message to them. And that was kind of fun, and I like that a lot. And again, it's all online. You can download all the bits and actually make your own should you wish to do that. But then I thought I'll go beyond that. I will go beyond, and so I did this. And this is the same phone with a bit more software on it, talking to a Raspberry Pi 5 in a box which I have called the Exchange. And the Exchange runs a large language model, and it takes what you ask it and gives you an answer. And here we go.
Ask your question.
How far is the Earth from the Sun? Now we wait a while the Exchange processes this, and the LLM takes the text, and then it rings you back.
Exchange. About 93 million miles away. The Earth is the third planet from the Sun, after Mercury and Venus.
And there you have it. And I'm very pleased that worked. What I have behind it is a large language model. There is the prompt for it, which is trying to sort of phone the chatbot line was kind of and you can have a lot of fun playing around with the prompt to make it behave in different ways when it answers the question. You can also fiddle with these sliders. This one makes the temperature one, makes it more inclined to get wacky on you. And so it's really a question of finding what works the best. And I had a lot of fun with this, and so I've now got this thing I can ring up and ask questions, and it will ring me back with answers, which I thought was quite good, using speech to text and text to speech. So the phone has the speech to text, and then it has text to speech as well. And yeah, I'm okay with that. It's probably well, I think I may have peaked on that one. And so let's have a look at the final thing I want to talk about, which is little boxes. Now these. What you might be looking at is thinking, my goodness, that stuff looks kind of hairy and big and expensive. Can I start with something small? And the answer is yes, you can. Little boxes are just that, really. Little boxes that contain extremely cheap processors. I'm just rearranging things here for the next video shoot. And you can run these things. You show a processor and an LED. And so you can make some remote controlled lights, or a processor and an LED and a button, and then you can actually press a button and make things happen and still have the lights, or a processor with a servo, so you can press a button and make it move something for you, or a PIR sensor which can detect a person and send a message, so I could have you walk up to the thing, that thing detects you, and that thing turns. Now this is all possible by a framework I've built that sits underneath all the boxes and controls what they do. You program it using very simple messages written in the JSON format, so you can tell it what to do. This is the code. It's called Hulos, because why not? It runs on 3 different kinds of microcontroller. It's a big C program. You can find it online, and it uses a thing called Platform IO in Visual Studio Code, and it's not a life's work, but sometimes it feels like it. And I have drivers for distance sensors and LCD panels of different kinds, and motors and all kinds of other pieces. It's also clock powered too, so you can tell it to perform actions at particular times, and you can set alarms that will trigger other actions and whatnot. And it's just fun to play with. And behind it is a whole bunch of server side infrastructure which I built up again just to see if I could do it. I wanted to learn how to write big web pages, and so I thought I'd better write a big system that had lots of pages. And so what I can do, I'll show you a box to start with. There's a box, and this is my whole CS50 light which I made, and it basically lights up with things, and at the moment it's showing green because that's the last command I sent it. If I go back in here and I just search through all my browser stuff, then that's the wrong one. Hey, wow, where's the right one? The right one is probably there. It is not. Oh dear. This is this one. Okay, so here's the deal. What's going to happen is that I'm going to drag this out of the way a little bit so we can have both things open at the same time. I'm going to put that over there. I'm going to go fetch the camera. There you go. So now this is my web service, and what I can do with this is I can say I want to make it red, and it will turn red. I want to make it blue, and it will turn blue. This is happening over the network. The fun thing is that I can actually pass someone this QR code. You can scan that with your phone, and then you get this interface, and you can then send it commands. And the even funner thing is that there's an interface you can use to actually build this web page. So this is a web page that's come out of a database that's been constructed by me giving it commands. I can probably show you them if it's being good to me. Let's have a little look. I'll go back to there. Come on, take me back. Take me back. Okay, that didn't go well, did it? Let's have a look here. That didn't go well either. Yes, okay. This is the thing about when you're giving presentations and you think, oh, I'll just show this. I'll make something up, and it always goes extremely well. Let's go back to here. Let's log into the portal. It has its own portal because, well, why would you not? And here we go. Now I can go into here and I can go manage all command groups. And at that point, it'll sit for a while it enumerates all the command groups. And it will show me all of them. And if I go to the CS50 Lite, which is this chap here, I can now edit that. And I can say, well, what if we want to actually, we've got 4 commands in here now, it looks like. I can add a new one. And the commands are, if I edit a command, let's look at a command, go on, we've got time. Let's have a look at what red does. So I've just hit red, and that should let me edit it, and of course it's not doing. Love it. You basically, this provides a binding between the thing and the thing. In a perfect world, it would be working wonderfully. Today's world is not. There we go. It's found it wonderful. The green command, okay? It sends this little chunk of JSON to my box to say turn green, and that's the prompt on the button, that's the description of it, and that's the device, which is basically a particular device on the network, and then you can basically send stuff to do stuff and whatnot, and it's quite fun. And when it works, it's completely wonderful. But you can do that, and I built this and I decided it was quite good, and you can access it from anywhere, and and wonderful, and it's all out there working. But then I wanted to control some robots, because that's what you do next. You make some robots and then try and get them to play rugby against each other. At least that's what I do next anyway. So this robot is Little Miss Sunshine, and she sits there and she's bright yellow, and I'll show you a picture of her in a minute. In the screenshot, she's running away. She's running away because she's a coward. If I wave my hand in front of her, she turns red and runs away because there's some code running inside her which makes her behave like that. And if I could just find the right window, this one here, I can show you what happens. Let's just prove that everything works, shall we? What I'll do is I'll put the robot in the middle. I'll stop the program running in there. I'll drag this box so we can have it on the screen, and you can all read my email now. Isn't that wonderful? Go away. So I've got this up here. I've got this up here. This is my robot. I can do something very similar to my commands. I can say red, and I can run that. That is a program. This is in the language called Pythonist, which I invented, and it will now turn that red. It looks a bit like Python. It isn't really Python. It's running on the device there, but I can, if I want to do it, I can go green, but not spelled that way, green, and then send that program to the device, and it will now turn green. And so I can give my robots commands and make them do stuff. I've got some sample programs, and one of these is called Robot Coward, Device Coward. Forever, that's a loop that never ends. Go green, measure the distance. If it's less than 100, go red, and move backwards 100. So let's send that, and it goes green, but if I wave my hand in front, it runs away, which is magical. And what I want to do, though, the fun I want to have with all this, is to try and get them all to play games together. If you had rugby teams or football teams or whatever, each person controlling a robot by putting programs into it and trying to push a golden ball around the playfield, that would be kind of fun. And I'm working on that at the moment. And we're also doing some robot tracking with Aruco codes to actually allow the robot to be told information about where it is on the playfield. That's going to be quite hilarious. If you want to get involved with that, then by all means get in touch and we'll see what we can do. Resources. Yeah, resources are good. These are my favourite microcontrollers. Everyone has favourite microcontrollers, and we've got ESP8266. It's got a Wemos D1 Mini, and that one costs you about £3 or £4 tops. This one here is quite expensive. This was about £6 or £7. This is a posh one. This is a Raspberry Pi Pico, and these two guys are ESP32 STM32 devices. And you can program these in Python or C++. You can write in C, Java, script, or even C# if you want. I want to use Rust for my next project because I've heard it's a good thing to know. You can write the code for these using tools like Visual Studio Code and Platform.io, which are also both free. And you can even, if you buy a little tool for about 10-12 quid, you can debug code running inside the device, which is completely awesome. All this stuff is free, works on PC, Mac, or Linux, including Raspberry Pi, and you can use ChatGPT, which knows a lot about embedded development, or at least it thinks it does. And so you can have conversations with that and design stuff for that. And it's all kind of great fun. So if you're thinking about getting involved in embedded controllers, you can do it for a lot less than the price of a night out. In fact, around the price of a beer will get you in. The coloured lights, the sounders, the stuff, it's all available at pocket money prices. It's very, very low cost. And you can make things to talk about. And you can take things that other people have built and modify them and use them in different situations and all kinds of good stuff like that. You can find the software I've written on these websites. It's still a work in progress and will probably always be that way, but we do have a hardware meetup in Hull every other Wednesday. You can follow my blog for details of that. So that's all on robmiles.com. We're in the library in the middle of Hull, which is it's a lovely place. We're in the makerspace there. And if you want to know what a makerspace looks like, you can come along and join the Hackspace folk and find out. That's all pretty much that I wanted to say here. I put some links on the end. Don't forget my blog, of course. But there's you can get your development tools from these guys. You can get your PCBWay, Next PCB and PCBWay are the two companies that will make your PCB for you. Those are good places to buy parts, and these are links to tools and software, and even Pure Data is down there at the bottom. So what are you waiting for? Go out and make stuff and tell people about it, and change your life. Why not?